On April 8, 2024, a rare spectacle graced the skies over North America. A total solar eclipse, a celestial ballet of the sun, moon, and earth, captivated millions. For a fleeting few minutes, day turned to twilight as the moon passed between the sun and earth. This cosmic alignment cast a shadow that raced across the continent, offering a breathtaking view of the sun's ethereal corona. Total solar eclipses provide scientists with unique opportunities to study the sun's corona, a region usually hidden by the sun's blinding light. The 2024 eclipse, with its extended duration and path over populated areas, offered a remarkable platform for scientific observation. Researchers armed with advanced instruments seized this moment to delve deeper into the mysteries of our nearest star. Understanding the sun's corona is crucial for comprehending its influence on Earth. By studying the corona, we gain insights into space weather and its potential impact on our technology-dependent world. The discoveries made during this event promise to advance our understanding of the sun's workings and its intricate connection to Earth. A total solar eclipse occurs when the moon, in its elliptical orbit around Earth, perfectly aligns between our planet and the sun. This alignment casts a shadow, known as the path of totality, on Earth's surface. For those within this path, the moon appears to completely obscure the sun's bright disk, plunging the sky into an eerie twilight. The sun, while about 400 times larger than the moon, is also roughly 400 times farther away from Earth. This serendipitous arrangement means that when the moon passes directly in front of the sun, it can precisely cover the solar disk, creating a total eclipse. The moon's shadow, however, is relatively small, covering only a narrow band on Earth's surface. As the last sliver of the sun disappears behind the moon's silhouette, the sun's corona, a shimmering halo of plasma, becomes visible. This ethereal aura, normally hidden by the sun's intense light, is a sight of both beauty and scientific intrigue. During this brief window, scientists scramble to gather as much data as possible, utilizing ground-based telescopes, high-altitude balloons, and even spacecraft. The 2024 total solar eclipse, eagerly anticipated by astronomers and skywatchers alike, presented a unique opportunity for scientific exploration. The event featured a path of totality that stretched across a large swathe of populated land, offering researchers easy access to prime viewing locations. This accessibility facilitated the deployment of a vast array of scientific instruments, from sophisticated telescopes to citizen science projects. One of the key advantages of the 2024 eclipse was its extended duration of totality. In some locations, the moon completely covered the sun for over 4 minutes, providing an unusually long window for observations. NASA, at the forefront of solar research, played a pivotal role in coordinating observations during the 2024 eclipse. The agency funded numerous research projects, deployed scientists to various locations along the path of totality, and even dispatched high-altitude aircraft to chase the eclipse's shadow. The wealth of data collected during the 2024 eclipse is expected to keep scientists busy for years to come. The discoveries made during this celestial spectacle are poised to advance our understanding of our nearest star and its profound connection to our planet. The sun's corona, a wispy halo of plasma that extends millions of kilometers outwards, is a region of intense heat and magnetic activity. Invisible to the naked eye except during a total solar eclipse, the corona has long captivated astronomers with its enigmatic properties. Its temperature soars to millions of degrees Celsius, far exceeding the sun's surface temperature of around 5,500 degrees Celsius. This discrepancy, known as the coronal heating problem, is one of the enduring mysteries in solar physics. The corona's intense heat is thought to be driven by the sun's magnetic field, a complex and dynamic force that permeates the solar atmosphere. Magnetic field lines, rooted in the sun's interior, twist and turn, storing vast amounts of energy. When these field lines reconnect, releasing their pent-up energy, they heat the surrounding plasma to extreme temperatures. Observations during the 2024 total solar eclipse provided scientists with a unique opportunity to study the corona's magnetic field in unprecedented detail. By analyzing the polarization of light emitted by the corona, researchers can map the orientation and strength of the magnetic field lines. These maps offer valuable clues about the mechanisms that drive coronal heating and the processes that shape the corona's intricate structure. To fully capitalize on the scientific opportunities presented by the 2024 total solar eclipse, NASA deployed a fleet of high-flying observatories. These airborne platforms, soaring above the obscuring effects of Earth's atmosphere, offered a pristine view of the eclipse. One of NASA's key assets for eclipse observations was the WB-57F high-altitude research aircraft. These modified bombers, capable of reaching altitudes of over 60,000 feet, carried telescopes and spectrometers to capture high-resolution images and spectra of the corona. Flying along the path of totality, the WB-57Fs extended the observation time for scientists. Another vital component of NASA's eclipse observation campaign was the use of sounding rockets. These smaller suborbital rockets, launched from strategically located sites, carried instruments to measure the corona's temperature, density, and composition. The combined efforts of these ground-based and airborne observatories provided scientists with a comprehensive view of the sun's corona during the 2024 eclipse. The 2024 total solar eclipse provided a wealth of data that will keep scientists busy for years to come. One of the key areas of focus is the coronal heating problem, the perplexing observation that the corona is hundreds of times hotter than the sun's surface. Observations of the corona during the eclipse, particularly those focusing on the dynamics of the sun's magnetic field, are expected to shed light on the coronal heating process. By studying how magnetic field lines twist, reconnect, and release energy, scientists hope to identify the key drivers of coronal heating. Another area of intense interest is the origin and acceleration of the solar wind. The corona, being the outermost layer of the sun's atmosphere, is where the solar wind originates. However, the mechanisms that accelerate this stream of charged particles to such high speeds are not fully understood. Observations of the corona during the eclipse, particularly those focusing on the structure and dynamics of coronal holes, are expected to provide valuable clues. The insights gained from the 2024 eclipse observations will not only advance our understanding of the sun, but also have practical implications for space weather forecasting. The scientific discoveries gleaned from the 2024 total solar eclipse extend far beyond the realm of theoretical astrophysics. The insights gained from studying the sun's corona have direct implications for technology development and future space exploration. One area where eclipse observations are expected to have a significant impact is in the development of more accurate space weather forecasting models. By improving our understanding of the processes that drive solar activity, scientists can create more reliable models to predict these events and their potential impacts on Earth. These improved forecasts will be crucial for protecting our technological infrastructure, including satellites, communication networks, and power grids. The study of the sun's corona during the eclipse also holds promise for advancing plasma physics research, a field with applications in fusion energy and advanced propulsion systems. These insights could pave the way for breakthroughs in fusion energy research, potentially leading to a clean and nearly limitless energy source. Furthermore, the 2024 eclipse observations will inform the design of future space missions to study the sun and other stars. The 2024 total solar eclipse, a celestial spectacle that captivated millions across North America, offered more than just a breathtaking view of the sun's ethereal corona. It provided scientists with an unprecedented opportunity to study our nearest star in detail, unraveling its mysteries and deepening our understanding of its profound influence on Earth. The discoveries made during this fleeting moment of cosmic alignment will resonate for years to come. The eclipse observations have provided valuable insights into the enigmatic corona, a region of intense heat and magnetic activity that plays a crucial role in shaping space weather. By studying the corona's structure, dynamics, and magnetic field, scientists hope to unlock the secrets of coronal heating, solar wind acceleration, and the processes that drive solar activity. These insights will not only advance our understanding of the sun, but also have practical applications for space weather forecasting, technology development, and future space exploration. As we continue to explore the cosmos, the lessons learned from the 2024 eclipse will serve as a beacon, guiding us towards a brighter future, illuminated by the light of scientific discovery.